talk about another design pattern called adapter design pattern. Okay. So adapter design pattern comes under structural design pattern category. Now let's explain this with a simple example. Now at your home, if you see, what happens is, like let's say you have a mobile charger or a laptop charger which consists of three pins, but at your home all your sockets accepts only 2 pin. Okay, all your sockets contain only 2 pin. Now to charge your devices like laptop and the mobiles, you need 3 pin socket, but that is not available at your home. Now you can't change your mobiles because mobiles or laptops accept only 3 pin connections, and you can't build a new socket immediately, or you can't break the existing socket and build a new 3 pin socket, right? So that's not possible. Here both the devices and the sockets that are available at your home are not compatible with each other, and both are not willing to change their interfaces. Now laptop chargers won't accept 2 pin connections, and even the socket also, you can't change from 2 pin to 3 pin immediately, right? So both are reluctant to change their interfaces, and both are not compatible with each other, right? So in this case, to solve this problem, what usually people do, they will buy an adapter. Now you have to plug in a 3 pin charger, but you have only 2 pin sockets at your home. Now what people adapter, if you see here, this is an adapter. What adapter contains is, here if you see, this 2 pin is the back portion of the adapter, and this 3 pin whatever you are seeing is the front portion of the adapter. Okay, now what happens is, it will cover the 2 pin socket. Basically your socket has the 2 pin, right? So when you plug this adapter onto your socket, what happens is, the socket is a 2 pin socket, because what you can see is, you can see only this portion of the adapter. So underneath the adapter, or the back portion of the adapter, whatever you have, this 2 pin or 3 pin or 4 pin, you don't know about that. What you just know is, you just see this 3 in your charger. So here what adapter has done is, it has converted this 2 pin interface to the 3 pin interface which clients need. So here client is the person who is charging their devices, and the clients are the persons, they need the 3 pin interface. So here they have, like what adapter has done is, whatever the client is expecting, it is exposing that interface. Here it is exposing the 3 pin interface, so that clients can use that interface. And underneath that, what it has done, it has done the 2 pin interface, it has converted the 2 pin interface to the 3 pin interface. Okay, so what it has done is, it has formed a shield over this particular socket, and it made that shield it not visible to the customer, whoever is using it. And what it is showing is, it is just showing the interface whatever client knows. It is hiding the interface that client is not compatible with. Okay, now let me explain another example. Let's say there are two persons, and one person knows only English and the other person knows French language, and now both person has to communicate with each other. Okay, now in this scenario, neither me, like let's say I know English and the other person knows French, neither me nor the other person are reluctant to learn, they are reluctant to learn other languages. Like I don't want to learn French, and the other person also don't want to learn English. So in this case, to make a communication these two persons, what you can do is, you can employ a mediator who knows both languages. Or let's say the person English to the French. Whenever I speak in English, what he does is, he can understand my language, and he knows the other language as well, and he converts it into the French. And if the other person speaks French, he knows French, and he will convert that to English, and he will communicate with me. So this way, with the help of a mediator person, the communication had happened between two persons, right? And these are all the real world examples we know. But there is also, if you talk in terms of a software, the examples we see are the legacy codes. Okay, now you all know, you would have heard about iterators and the enumerators, right? So both are used to traverse the collection, right? So what happens is whenever you have a collection like list, linked list and all, when you want to print all the elements that are present in that particular list, what you do? First, you will get the iterator. So whenever you have list has a method, okay, list dot get iterator of. Whenever you get the iterator on the list, what you can do is you can invoke these three methods, has, next of. Using those two methods, what you can do is you can traverse the elements that are present in that particular collection. Okay. Now, the methods that are present in Java before, it used to use the enumerator. Okay. Enumerator works on vectors. Okay. Vector is also a collection. What like enumerator also works the same way as the iterator. Okay. Enumerator has two methods like has more elements and next element. If you see closely, has more elements is analogous to has next, and the next element is analogous to next of method. Okay. Now what vectors, whenever you do vector dot get iterator of, it will not give you this iterator because vectors work with enumerators, and that were developed long ago. Later on, iterator had come into the picture, and iterator works for all other collections. Whenever you try to fetch, like if you want to traverse the elements that are present in the vector collection, what you have to do is you have to first vector dot get enumerator, you have to get the enumerator, and then you have to invoke these two methods on this enumerator, on the enumerator that you have fetched, and then you have to traverse the elements. Okay. But if you see it, let's say I am the developer and I know only about iterators, or I want to write a unified code. Now in this case, since I want to write, I don't want to, because enumerators long ago and those are the legacy codes, I don't want to, I don't want my code to be written in the legacy code format. Okay. Now what I am writing is I am writing some generic method to iterate the collection. So what I'll do, first I'll fetch and then I'll do collection dot get iterator of I will do. Now when I do that, but while doing so, if you encounter a vector, when you do vector dot get iterator of, you don't get that. So to traverse the vector, what you have to do, you will write another block of code. Okay. And in this block of code, what you will do vector dot get an enumerator of, and then you will write the piece of code related to the enumerator. But if you see, okay, and if developer like me doesn't have knowledge about the enumerator, then I can't traverse it. And moreover, you have two pieces of code which do the same thing for the collections. Okay. In this case, what you can do is, since this is the legacy and you want to use your only the new interface, what you can do is you can write an adapter class. Okay. So as you know, adapter is the one which converts one interface to another interface. Now being a developer, what I want iterator interface for all. Okay. Now this adapter class should implement iterator. So in the last, whatever I was showing you, whatever the client is expecting, it should, right? Here when you have 2 pin and the 3 pin, client needs 3 pin. So it socket. The same way here, client iterator here. So it will implement the iterator. When it implements the iterator, what happens? Adapter will become iterator. Okay. Now I can use this adapter. So here also what we have done, this particular adapter, it is showing the 3 pin a client wants. Okay. Now since it is showing the 3 pin, what client assumes is, okay, my laptop charger's interface and this interface is same, and I'll use this adapter. Okay. Now in the same way here as well, what you have to do, since you want to work with you want to use iterator for all your collection traversal, whatever the adapter you have written, it should implement the iterator, because you need the iterator interface. Okay. And now whenever, what happens is, for list and all, you need not write any specific implementations. Has, next of will work, okay, because these are the default implementations that Java is already given. But for vector works only with the enumerators. But since client does not doesn't want to know about the enumerators and it wants to work with iterators, what you have done is you have implemented this. So what you can do is has, next of and next of. Whenever a client invokes has, next of and next of, what you can do is you can delegate that call to has more elements, and you can delegate that call to next element, okay. That's what you can do. Here also what you have done, client is showing the interface whatever client is expecting. So here also you have written an adapter, okay. Here this class is nothing but this adapter, and this will be this interface is same as the client or the target interface, right? Client interface, because whatever client expects you should show that. And here inside what it has, class methods to the enumerator class methods, okay. Yeah, this is one example, and I'll show you one more example as well. Let's say you have two interfaces, two animals called duck and turkey, and you have written interfaces for duck and turkey as, let's say, duck interface has quack and fly off methods, because duck can quack and duck can fly. And in the same way you have a turkey as well. So turkey is another animal. What it can do is it can gobble and it can fly. But you have seven, right? You have mallard duck, you have other varieties of ducks. Even if you consider the dog also, there are several breeds that dogs, okay. So this is a common interface for all imitations. Like mallard duck is one of the subclass of the duck, okay, and there are other ducks as well, okay. And even if you consider the turkey, what you have is you can have the wild turkey and you can have other varieties of turkeys as well. Now here you have two interfaces, duck and turkey, and let us assume you are developing a game, simulation game, okay. So in the simulation game, instances of the ducks, so you need instances of the ducks, and then you were able to create only 90 instances of the ducks, and you have a shortage of 10 ducks. So now what you will do is can fly. The only difference that between duck and the turkey is quack and the gobble methods, right? So what I will make turkey look like duck, okay. If I do that, so I will make turkey look like duck. So if I do that, it's not a turkey. So whatever the shortage I have, those 10 ducks, I'll make use of turkey and I'll produce those 10 ducks, okay. So here even you can just what it has done here. So here, is right. So the same way you will do. So you will write an adapter class to convert turkey to the duck. Here you have developed and you have used an adapter to convert 2-pin to the 3-pin. Here you will use an adapter to convert turkey to duck. So inside the turkey, see the class diagram of the adapter pattern. So in the class diagram you have 4 key players: client, target interface, adapter and the adaptee, okay. So client is the one who is target interface, okay. Now if you consider this adapter example, client needs 3-pin socket, okay. Now here the client is this is the target interface, because ultimately this is the interface that whatever client is the person who is working with the interfaces, okay. Now client needs 3-pin interface, so the target interface is the one which is required by the client, okay. And here what it has done, converted 2-pin socket to 3-pin socket. What it is converting? It is converting 2-pin socket to the 3-pin socket. So what is getting converted here? 2-pin socket getting converted. So 2-pin socket is called as the adaptee, okay. Now you have two interfaces. One is the 3-pin socket and one is the 2-pin socket interfaces. Both are not compatible. To make these two compatible with each other, you have written an adapter class. So adapter class testing. So whenever you write an adapter, here the client needs 3-pin socket. So you should make your adapter look like a 3-pin. So to make it look like target interface here, your adapter should implement the target interface. When it implements that, so adapter is a target, right? Adapter is a target interface, okay? Now, when it implements the target interface, then whatever the adapter you have written, it resembles the target, right? So here what had happened is target interface is a 3-pin socket and adapter is the 2-pin socket. And whenever client uses this adapter, okay, so since adapter is implementing the target interface, adapter is a 3-pin socket. People think that it's a 3-pin socket, but underneath what is in the back end, what is happening is it's getting converted to the 2-pin. So the same way for duck and turkeys as well. You want to convert turkey to the duck. You want your turkey looks like a duck, right? So what you have to do, you will write an adapter. But that adapter, here if you consider this, the target interface is turkey should look like duck. So adapt is the one which is getting converted. Here turkey is getting converted. So here adapt is the turkey. It is getting converted to duck. Okay, here the target interface is the duck. And whatever adapter you have written, it should implement the duck, because the adapter should implement the target interface, right? So here turkey adapter implements the duck. And what happens is this adapter holds an instance of an adaptee. So here if you see, this will holds an instance of the adaptee, because if you see physically you have an instance of an adaptee, and whenever a client makes call to this target interface, you will delegate those requests through methods that are present here. To delegate the request, you need instance of an adaptee, right? So adapter will hold an instance of an adaptee and it uses composition, okay? So here adapter will hold an instance of an adaptee, it uses the composition, and whenever not a duck, it's a turkey, right? Whenever people makes call to this adapter, what happens is it will internally delegate those calls to the turkey. The same thing had happened here. People think that this is a 3-pin socket, but ideally it's not a 3-pin socket. Whenever you make a call to this 3-pin socket, it has actually underneath the connection is the 2-pin socket connection. It will route the request to the 2-pin socket, right? The same thing is happening here. Now you implemented the duck interface, and whenever request comes here, you route it to the turkey, because turkey is the actual physical instance that is present, okay? Now let's see the same thing with the enumeration iterator. So if you have seen this enumerator and the iterator, what you want to do, you want this enumerator also look like an iterator. So here if you compare this with the class diagram, you are converting iterator to the enumerator, because vectors works with the enumerator. But since clients need iterator interface, so the target interface will become iterator interface, right? And then vectors actually has an enumerator instance. Enumerator instance is getting converted to the iterator. So adaptive will become enumerator. So whenever you write an adapter, adapter should implement iterator, right? So what I have done is, this is an adapter I have written and it implements the iterator. When it implements the iterator, whatever methods that are present in the iterator has next of and the remove of, you can provide your own implementation. So for vector, what happens is it really does not have any iterator instance, because vectors work with the enumerators. Vectors has this enumerator instance. As I have already told, adapter will hold an instance of an adaptee. So here this adapter will hold an instance of the enumerator, and whenever it makes a call, whenever vector makes a call to has next of, you can do enumeration dot has more elements of, okay? And you can convert other vice versa also. Like let's say people want to use enumerator for all, but few of the collections are using iterator. So here you want to convert iterator to the enumerator. So you will implement enumerator, and whatever methods that are present in the enumerator, you can, whenever request comes to this enumerator, you can route it to the iterator, okay? Now let's see with some working example. Now if you have seen here, you have created an instance of the duck and you have created an instance of the turkey. But what you want your turkey look like a duck. So you do that using this adapter. So to the adapter, what you need an instance of an adaptee, right? So you pass the instance of the adaptee. So when you pass this, finally people think that this is a duck, but internally it holds an instance of the turkey. And whenever you invoke duck.quackFly, what it does is it will delegate those requests to the turkey, and whatever whatever methods that are present in the turkey will get invoked. Okay. Now this is the class diagram of this, and if you see here, these two are the interfaces, both target interface and the adaptee. Now if you see the duck here, duck is the interface and the turkey is the interface. But if you see the adapter class, what you are doing is you are implementing the target interface and it holds an instance of the adaptee. Now turkey is the interface, and in like turkey can have multiple subclasses like wild turkey, other turkeys as well. Now here you can pass any instance of the turkey. It need not be just a wild turkey, right? So with the help of this adapter pattern, what you can do is you can work with multiple subclasses, not just the wild turkey. Okay. Now if you see whatever the pattern we have discussed till now, this is called the object adapter pattern. So there are two types of adapter patterns, object adapter pattern and the class adapter pattern. So in the object adapter pattern, you use the interfaces and you use composition to interact with adaptee. There is another approach. Here what happens is, these are the classes, these are not the interfaces, these are the specific classes, and you it will implement it. Okay, here multiple inheritance is there. Though this is not possible in Java, you can implement this in other coding languages. Okay, now what happens is adapter will implement both target class and the adaptee class, and whenever request goes to the target class, it will invoke method present on the adaptee, because you have only physical instances of the adaptee but not the target, right? So but the advantage here is it's using the inheritance, and one more thing is it is implementing the specific class adapter pattern. Now it will implement here. If you see, I am implementing the interface. So if I implement the interface, I am coding to an interface, not an implementation. So using that, you can change duck or any subclasses, right? Even in the turkey also you can use any child class of the turkey. Now this is the object adapter pattern, right? If I want to convert this class adapter pattern, what it has to do, it has to implement both the target class and as well as the adaptee class. Here the target class is, let's say, duck, mala duck, and the adaptee would be the wild turkey. Now it will not hold this instance. Okay, now what you can do is, let me show this, and now you will not hold any instance. Whenever you do the quack, before you were using turkey.gobble, now you can directly use gobble, because you are implementing the wild turkey and gobble method is already present here. Okay, you can do the turkey.fly. But the disadvantage here is you are using the multiple inheritance, and one more thing is you are working with the specific classes. Okay, yeah. So if you understood it clearly, what adapter does is, there are two interfaces that are present and both are not compatible with each other. To make these two compatible with each other, you will write an adapter class which will convert one interface to the other interface. Here it will convert adaptee interface to the target interface, and whenever request comes to the target interface, it will translate that request to the adaptee interface. Okay, yeah. That's it about the adapter pattern. Let's see the definition of this. If you see the definition of adapter design pattern, adapter pattern converts the interface of a class into another interface that clients expect. So here it is converting the interface of a class 2-pin socket to the 3-pin that the client is expecting, and adapter let classes work together that could not otherwise because of incompatible interfaces. If there is no adapter, people can't in their charges, and if there is no adapter, persons who doesn't know English or French can't communicate. If there is no adapter, people can't work with enumerator same as iterator. And if there is no adapter, you can't make turkeys look like ducks. So there are so many examples of the adapter. Okay, yeah, that's it about the adapter design pattern.